Hello friends, welcome back to Online Math. We have this interesting problem right here to solve. So what we have is 2 power x plus x is equal to 7. Okay, so we want to find out the value of x that is actually going to satisfy these problems. If you need to our channel, do what to hit the like button, subscribe to our channel, and then of course once you're done doing that, we're going to delve right into this video. So the first thing I want to do is actually to subtract x from both sides so that I can actually move this x to the right hand side. So if I do that, I'm going to be having 2 power x is equal to 7 minus x. Okay, so the next thing I want to do is just to go ahead to divide through by 2 power x. Okay, so that this cancels this, and then I'm having that 1 is equal to 7 minus x and then divided by 2 power x. Okay, so for the sake of convenience for me, I am actually going to write this one first and then I'll move this one to the left hand side. Okay, so if I read that, I'm going to be having 7 minus x divided by 2 power x is equal to 1. Okay, so the next thing I want to do is actually to write this stuff right here. So I can actually write this as 7 minus x and then all multiplied by 2 power negative x. Okay, and of course it's all equal to 1. Okay, so next I will want to find a way to have this same thing that is at the base right here at the power here, because of course we're actually going to be utilizing the Lambert W function to solve this problem. And just like you've also seen in so many of my videos where we've applied the function to solve other interesting math problem, you often see that for us to apply the Lambert W function, we always want to present in our function to be in the form of a exponential a, so that once we apply the Lambert W function, we're actually going to have a to be the result of this. Okay, so our job is just pretty much simple to find a way to simplify all of these, especially the left hand side, to be in the form of a exponential a. Okay, so since we've got 7 minus x right here, and then we only have minus x here, we want to find a way to get positive 7 right there, and we can achieve that by multiplying both sides by 2 power 7. Okay, so if I do that, I'm going to be having 7 minus x, okay, and then of course multiply by 2 power negative s multiply by 2 power 7, okay, and then it's equal to 1 multiplied by 2 power 7. So I'm actually going to apply the rule of indices right here. Since they have the same base, I'm going to pick one and then I will add the powers. So I'm going to have 7 minus x, okay, and then of course 2 multiplied by 2 power x, okay, and then plus 7 right here is equal to 1 times 2 power 7 is same as 2 power 7. Okay, so at this point you can see I've got the same thing over here, so I can even decide to write this one here so that it will look like this one that is at the base. So this is 7 minus x multiplied by 2 power 7 minus x, okay, and of course is equal to 2 power 7 is 128. And so we've gotten to the point where we have 7 minus x as the power here, and then of course 7 minus x as the base. But then we also want to introduce this exponential sign right here so that we can go ahead to apply the Lambert W function. Okay, and of course it's just pretty much simple for you to see that we can actually rewrite this 2 power 7 minus x as equal to the exponential of the natural log of 2 power 7 minus x. Okay, and of course I have not done anything because exponential of natural log is equal to 1, and then 1 multiplied by 2 power 7, this is 7 minus x, it will still give you the same thing. So in place of this 2 power 7 minus x, I'm going to write the whole of this exponential natural log of 2 power 7 minus x. So what I had initially was 7 minus x, okay, multiplied by 2 power 7 minus x is equal to 128. So if I substitute what the exponential function right here, what I'm going to be having is 7 minus x multiplied by exponential natural log of 2 power 7 minus x. Okay, and of course it's still equal to 128. Okay, so I am going to apply the rule of natural log right here. So I'll bring down this 7 minus x here. So I'm going to be having 7 minus x, okay, multiplied by exponential 7 minus x multiplied by the natural log of 2 is equal to 128. Okay, so at this point you can see that we are almost there. The only thing that is just remaining for us to have this function here in form of a exponential a is just for us to find a way to attach log 2 to the base right here, and we can achieve that by multiplying both sides by log 2. Okay, so we're going to be having 7 minus x and then multiply by natural log of 2 exponential 7 minus x, okay, natural log of 2 is equal to the natural log of 2, okay, and then of course multiply by 128. Okay, so you can see that we have gotten this side as a exponential a, where our a is 7 minus x multiplied by the natural log of 2. Okay, so we can go ahead to apply the Lambert W function. Of course, when we do that, we're going to be having a Lambert W function of 7 minus x, okay, natural log of 2 exponential 7 minus x, okay, natural log of 2 is equal to the natural, let me write this first, 128 multiplied by the natural log of 2. Okay, so I will still take the Lambert W function of this side, and of course this left hand side here is actually going to collapse to 7 minus x multiplied by the natural log of 2. Okay, and then it's equal to the Lambert W function of 128 natural log of 2. Okay, so at this point what I'm going to do is just to go ahead and divide through by the natural log of 2. Okay, natural log of 2, so that this cancels this, and then at the left hand side I'm going to be having the 7 minus x is equal to the Lambert W function of 128 natural log of 2 divided by the natural log of 2. Okay, so that at this point I will just make x the subject, so I can do that by moving x to the right hand side so that it actually changes to plus, and then I'll move this one to the left hand side. So I'm going to be having 7 minus the whole of this is equal to x. Okay, so x is now equal to 7 minus the Lambert W function of 128 natural log of 2 divided by the natural log of 2. Okay, so this is actually going to be the value for x, but then you may also want to find out the decimal representation of the value of x. So you can go over to wolframalpha.com so that you actually get the decimal approximation of what x is. Okay, so if you go there to compute it, you're actually going to be seeing that this stuff you see right here is 4.7516. okay, and then of course when you subtract this, you're actually going to be seeing that approximately s is going to be equal to 2.2484. okay, so this is actually going to be the approximate value of x, and I hope you've understood the steps we took. Okay, and then if you have any question, do drop it in the comment box and we'll get back to you guys. Make sure you like this video, subscribe to our channel for more updates, and I'm going to see you guys in my next video. Bye.